This is the one flight. This is the one flight. And as I told you earlier, half of this load is going to be transferred upside, half of this load is going to be transferred downside. We are designing this slab as a one-way slab. We are designing this slab as a one-way slab and transferring the load in this direction, transferring the load in this direction. So what will happen? Slab is going to transfer the load to the supporting element. That is what the beam. Beam will be there, and beam is ultimately going to transfer the load to the supporting column. So what normally some consultants they are doing, they are calculating whatever the load this slab is going to transfer to the beam. After calculation of that load, they are directly going to assign that load to the beam. So in that situation, what actually needed to do? We don't need to model the slab. We don't need to model the floor slab. We don't need to model the actual staircase. We are doing the calculation on some other way, some other place, and that loading we are going to put over the supporting element, either to the beam or either to the directly column. So these are the three approaches. Very first is what? Actual modeling of the staircase. In model, here what? In model, call staircase we can model. In this model, we can model the staircase. That is what the first approach. We don't need to do calculation. We don't need to assign to the supporting element. That nothing we need to do. Software will do everything. We just have to model the staircase here. But why consultants are not going to model it? Because it's taking some time. It's taking what time to model the staircase. That's why to complete the work within a given period of time or within a short period of time, consultants what they are doing, they are not willing to model the staircase. They are not willing to model the staircase. So this is what the first approach, actual modeling. Actual modeling. Second, what? This is the approximation. Second approach is what? The approximation. Instead of modeling of the staircase, what they are going to do? They are going to model the floor slab. They are simply going to model the floor slab as similar to that of the other floor. So normal floor slab, normal floor slab, floor slab. And in the third option, what they are doing, they are not going to model the staircase, they are not going to model the floor slab, they are going to do the calculation of the staircase and going to apply to the supporting element. Understood or not? Hello?
Yes, sir.
So in this training program, I will let you know the first option. We will discuss the first option, actual modeling of the staircase, and we will discuss the third option, doing the calculation manually or by using the spreadsheet, and we will assign to the supporting element in the high-rise structure. So these complicated options I am going to cover in this training program. And second is what? Normal floor slab modeling. So that is not much complicated that you can do. What you need to do? Just simply you need to model the slab for the staircase position. For the staircase portion, we have to model the slab and you have to assign the load over that. That's it. Wait for a minute. Yes, audible? Hello?
Yes, sir.
Yeah. So let's try to understand how to model the staircase in the model. Okay. So first we need to come to the ground level. This is what our ground level. So from here, our staircase flight is going to start. Our staircase modeling is going to start. Okay. See, this is what the ground floor. At the ground floor, this beam is present, and that we have not modeled here. So first we need to model that beam. First, we need to model that beam. Okay. So how much the span that we need to check here from this point to from here. This is available at this, check it at 1.42 meter. So go back to your ETABS and take the frame and beam will be what? We need to check the beam 230 by 500, close it. Make sure that you are working with the one story option. Don't do the mistake. Thereafter, At offset distance, okay, we have not given the defined the offset distance. How much offset distance is there? So it is actually 1.420. Okay, so 1420 in mm. Close it. From this point,
Welcome you all in ISO certified live training program ETABS, RCDC and Excel that makes you a professional structural engineer. In this training program you will learn everything about ETABS and RCDC from basic to advanced, real life project of medium rise structure from architecture plan to final design sheet, real life project of high rise structure with all advanced topics, design of structural elements using advanced Excel sheets. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next.